And we're going to get started here. How did everyone like the Git presentation from the morning? Yeah. It was very, very in-depth, I'm sure, right? Yeah. A lot more goes behind the scenes than we think, but it's not magic. I think that was his main point, was just remember that when it comes to Git, like everything's happening for a reason, but it's not any sort of magic going on behind the scenes.
Okay, I just want to make sure I'm clear though. So when we like installed and like got the software set up on our computers, we installed Git onto our computer.
That is accurate.
Okay, so Git is just a program, like a file sorting mechanism that we use within our terminal, and that can communicate to outside websites and repositories and whatever.
It's accurate.
Okay, cool.
And on the top, let's just get like I said, like we have to pay for the fee. Like you said, because last time you said, okay, we got someone like support non-profit organization, and you don't have to pay for the fee, right?
There's GitHub and then there's Fox.
Yeah, it's like
Fox something.
I mean, and he showed like the GitLab or something like that. And
It was a private something. It was
I don't get the point why we have to pay for that.
It was DRW's. It was DRW's like, right? They outsourced it.
It's like Google Drive versus other paid storage drives. I mean, I'm sure
Say
they
the
have
Dropbox with like.
Yeah, sure.
Yeah, you pay for.
Yeah.
Hmm.
It's just like
Yeah.
Do we pay for GitHub?
no.
Are you talking about that?
GitHub is free.
Right, but I mean why they need the GitHub for? I mean GitLab for, because GitHub is free, right?
No.
I think they use GitLab for security. I don't
See,
know.
like unlimited private repositories stuff costs money.
So almost all the software that you have on the internet is like freemium software, meaning that it's free up to a certain point. If you want to get any sort of like big features that you'd actually want to use in a company or you would want to use personally, then you would have to start paying. So GitHub by itself is free. The way that we use GitHub would cost money, but because we're a nonprofit, they say like, here's a coupon, you can do whatever you want with it forever. Like we don't have to pay for it. But if you are a regular developer and you're working on things and you want to have a lot of private repositories and things like that, stuff you don't want other people to see, you'd have to pay $7 a month. GitHub is just one of many online vendors to host your Git software. So there's GitHub, there's Bitbucket, and there's another one called GitLab. GitLab is open source. It is they have all of their software is free and online. You can use it, but again, it's one of those freemium things. You can use it. It's free. It's online. All the code is open for everyone to see. But if you want more advanced features, then you have to pay some money.
Do we have any idea how many users are on GitHub? Like, what's the market split?
I don't know, but I would say most people use GitHub. That's all I can say. Most companies and most people use GitHub. It is the most common one. So how we'll structure this afternoon is, since we have so many different things that we want to cover, what I'll do is, and because today is an individual working day, I'll cover one topic at a time, and then I'll kind of like announce when we're starting a topic, when we're ending a topic, so that you can either pay attention or you can work as you want. Before then, I just kind of want to give you an idea of what's coming in the next 2 weeks. So tomorrow we were supposed to have an assessment. I think we're going to push that one off to Monday, giving you the weekend to kind of study up and kind of internalize some of the things we're covering today. We'll do a check-in tomorrow, have a retro, and then at 1:30 we'll have our diversity and inclusion beyond tech. We're not going to have it today. Next week is week 4. We're going to do a bunch of SQL. So on Monday morning we'll take the assessment, and then Monday afternoon I'll teach some intros to SQL. It's mostly DIY for that one. Tuesday, HashRocket will be here all day to teach on SQL. You met some of them last week. I'll be out Thursday, Friday of next week. There was supposed to be a group on this, but they switched it to October 27th, so we'll be going at that point. And something really to look forward to the week afterwards is we're going to go to Chicago Ideas Week. Oh no, that's 4 weeks from now. This one, we're going to Table XI. They have their own. It's a consultancy here in Chicago. They have their own in-house chef, so they'll be fixing us lunch. I think past 2 times were like they had like ribeye steak for lunch one time, and then they had like
For the team?
for the team.
Holy
The team's
crap.
not very big. The team's only 30 people, but
30
that's
ribeyes? Yeah.
no. I mean, it's not 30 ribeyes. It's not. It's not. Each person gets one whole steak. It's like they cook the ribeyes, they rest it, and then they slice it, and then you pick some slices. You could take the entire steak, but it's not like 30 ribeyes for lunch. You know, it's not like that. So yeah, just something to look forward to. All right, so I want to review modules, and then we'll finish up like the recording at that point. I'll just kind of like marry the 2 recordings together so it's one giant recording. And then I'll have a session on object-oriented principles. I'll just do a quick review, and then whoever wants to pay attention can join in on that. Then we'll do stuff on hash instantiation versus just listing out all the arguments in a row. We'll do super and inheritance, and then we'll finish out with CSV. That'll probably take us the afternoon. Again, pick and choose what you want to listen to. You can work otherwise, but I'm sure some people want to go over each one of these, but I don't want you sitting here for 3 hours if you don't want to. All right, so let's talk quickly through modules. So there are 2 main ways that we're going to use Ruby modules. The first one is for something called namespacing, like we talked about this morning. So if I had a random class called account or something like that, account is one of those things that's it's too general, it's too broad. You want something a little bit more specific. So account, you could have a savings account, you could have a checking account. And this is one way to combat like that ambiguity when we talk about things when we're talking about specific things like account.
Are you recording?
Yeah. Yeah, I'm recording. The other way that we can do it is that we can use modules to namespace our classes. So we have a module called account, and underneath it I have something called like class savings. That might take a owner name, maybe a number. I can also access this way. So I can do account : savings.new, and I can have a new owner of John, and my number is 12345 or something. That might be an account number. This way, when I look here, it's not just account.new. It's not account.new like John and 12345 because that's ambiguous. You don't really know what that's there for. It's not savings.new. It's actually going to be account : savings. So this is a way to like name your classes and your variables in such a way where it makes it easy for other people to understand like what is going on.
So previously, before we had this module, we just had class like yesterday, the day before.
Yeah, I mean you don't have to use this module.
Yeah.
You really don't. I just want you to be aware that that's what's going on.
Okay, but so previously we could do savings.new John 12345.
Yeah.
But now because there's a module class before it, we have to call it the module class. It's kind of like going into the right library, like the right folder.
Similar, yeah.
Okay.
Yeah. So again, you could do account.new. That's ambiguous. I don't know what type it is. I could call it savings account. That's totally fine. Or you can do it this final way of account : savings. This is just a way to name your classes effectively.
How would account.new? It could accept those arguments even though it's not within the class.
Well, it is. So it's kind of like I'm looking for an account. Underneath account, there's going to be a class called savings, and then I'm calling .new.
I'm saying if you took away the savings.
If I took away savings and I did this,
Yeah.
This is nothing.
Well, I thought you just said that you could take away savings.
Oh. I'm saying there are multiple ways of writing the same thing. Let's say like you wanted to create a program, like today you're going to do something called bank accounts. If you wanted to do something that took into consideration savings accounts, I could do it multiple ways. I could just have something called savings account, and without a module around it, and then I can just do
Savings account.new.
savings account.new. Yeah, exactly what you're more or less used to right now.
Okay.
These two are synonymous. They both do the same thing. It's just one is, it's the same thing. You just get to figure out which one works better for you.
Yeah.
Some people really like this account : savings because I think it's easier to organize that way. I personally don't find it more or less useful. I'm a bigger fan of line 34 here, where it's just like class savings account. Just name your class as well.
Yeah.
Is what I say. But I mean, you're going to see things like when I read and write to a CSV, you're going to get like CSV row. Like if I have just the class name called row like this, it's not especially descriptive. It could, what kind of row are you talking about? Now I have CSV. It's saying it belongs to the CSV class, the CSV module. This row in particular is in the context of the CSV. I could just as easily, they could have just as easily done like CSV row like this, but that's just how they chose to do it. So this is one decent way of using modules. It's just for namespacing. How do I organize my classes and my variables? But the more popular way of doing it is using what's called a mix-in. And what a mix-in is, it's just a bucket of methods that you can basically move from one file into another. Now, every single person has the ability to have teenager methods if you wanted to. Every single high schooler has the ability to use these teenager methods. So that's kind of what we created here. So we had class person. We said every single person, adult, baby, adolescent, everybody has a first name, a height, and a weight. And they're able to say hello. At a certain point, a person, like a young child, is going to become a teenager, and then they're going to get a brand new set of methods that only teenagers, or that are specific to teenagers, right? Giggling at the mall is something that's specific to teenagers. Giving sass and just going ugh, whatever, that's specific to like teenagers. So instead of saying like I'm going to throw this give sass directly on the person, which is totally fine, you can just say like a person can give sass. I create a separate module which is more or less a container for external methods that are not dependent on a person, or not dependent on any sort of variables. And I can just drop it in here by requiring relative to the file and then just including the teenager module. By having this include teenager here, I basically give the ability of just copying and pasting all of the methods inside of this module teenager and pulling it inside this person.
And when we're doing like requiring file name or requiring CSV, that has to be within the same, I don't know how to say it, like on your terminal, it has to be within like the same file, right?
The same folder, yeah.
Folder, yeah. Like I can't pull a CSV from like somewhere else in my computer.
Well, it's relative to where you are right now, right?
Yeah.
So if I open this up, you can kind of see that high schooler, person, and teenager are all at the same level. But if I were to put some other folder inside of here, and let's say I throw the teenager inside of here instead, if I'm operating off this person.rb, teenager is not in my immediate vicinity. I have to tell the computer exactly where it is.
So there's probably another command for that or something.
It's actually just, so let's say I'm this person and I want to get to the teenager module.
Yeah.
The file structure looks a little something like this. Here I am, person up top, and I'm right here. I need to get into some other folder and then the teenager file. Yeah. So if I were to run this person right now, ruby person.rb, it blows up because it says require relative. I can't load that file. It's not where you said it was. By not having, by the teenager not being right next to it, it's not going to work. So what I'm going to do is I'm going to just write some other folder, and then slash teenager. And I believe at this point it'll function. This is something else. Let's read what's going on here. Okay, module example, some other folder, teenager RB, line 3, undefined method, raid. I'm not sure what's going on here. Oh, oops. There it is. I was altering the original, and was not in the same. I was not in the file that I had actually moved. So let's get rid of this grade thing. So again, that require relative is I'm saying I'm bringing in a file relative to where I am right now. So person.rb, you take a look, is at this level, and I need to get inside some other folder to teenager. This is garbage. So it's kind of like where is teenager relative to me right now? I have to go into this folder and then up here. And similarly, if I wanted to move teenager out from where I'm at right now, and I moved it into one level up, then I have to give it that path to get there as well. So instead of doing some other folder, I have to go out one level, which is ... and then slash teenager. And I believe if this works correctly, then it will still run. Teenager back into module example. This. And move this back to where it was. So Mickey, what is a module?
Module is like the way you set up like a class as a separate class. You can just like what you did. You set it like class like checking account or saving account to be those kind of stuff. You can just set up module as the whole accounting and just be specific like checking and saving.
Okay.
And the way you call it, you can just use record like that.
Okay, that's good. So that's one aspect. So module is a good thing for namespacing. How do I name my classes effectively? What is the other way that I use a module?
You actually use it to refer like between different files. Like when you use a module as an interface between instead of you implement like the whole class to another file, you can just use this separate file, and you can just call the module from the middle file to.
That's not entirely false. So that is technically true. I'm able to put a bunch of methods inside this module teenager, and this module really is just, imagine just a bucket. I'm just throwing a bunch of stuff in the bucket, and then it's kind of like you can take that bucket and just move it between different classes. You can include it at different points.
So like what you were saying earlier, I think it was just basically like you could be a high schooler and a student. So you invoke high schooler and then give SAS. Right?
Yeah.
So that's what you mean by borrowing from the module. It's such a general bucket that it could be. All you have to do really then is just to require it.
And then include it right here. Exactly. Yeah. So it's kind of like I have a class person and then I have a class high schooler. These are two different classes, but let's say they both have the ability to include a bunch of like teenager methods, because a person can be a teenager and a high schooler could also be a teenager. There's teenage methods specifically. There are methods specific to teenagers that you can include on this class. So let's say your kid is like when you have a son, right? At one point, your son's going to stop being, well, I don't know if this is true, but I feel like your son's going to start off super cute, and then at a certain point they're going to turn into a teenager, and then they develop like a more of an attitude, and they'll push back a lot more, right? So at that point, they will.
I wish I could put it off and say the teenager.
Well, it'll get worse when he's a teenager. Let's put it that way. At that point, he's a person. He's a high schooler. There are teenage methods that are going to come in at that specific time. And after a certain point, you may not need to use them. Like that person may not have the teenage methods anymore. Like when they enter young adulthood or become like 30 or something like that. Then you don't need to include the teenage methods anymore because that person has grown out of their teenage years. But I still have these reusable methods inside this module, which basically is like if you have another kid, then you can put it in that kid's methods, available methods. Yeah. Or you can kind of think of it as there are parenting lessons that you've learned from your first kid, right? Things that you're kind of putting in your memory bank that you didn't know to begin with. But now it's like, now you know how to change a diaper. Now you know how to do all this kind of stuff. And you kind of throw all of those methods inside of a module of like, take care of baby. Now take care of baby is part of you. You can like go to any child, or if you have another child, you're able to, you have that thing built in that previous context of, I know how to change a diaper or something like that. Not the perfect analogy, but it's basically reusable things that you can that you can use between different classes.
So, in like terms of what we've already done, if we created like for the ice cream exercise, if we had different classes for each flavor, we could have a module to put in the freezer. That's a general. We could have the general method within the module that we put the various classes of ice cream into the freezer.
Yeah, that is something that you can do.
Nice.
Yeah.
On this one, what you for the model teenager, if you take the model teenager out and you just create like a method, right? And then you also can use another file to call the method.
You can use another file to call the method.
Yeah, like
Class.
yeah, like if you create like instead of you use a model as a teenager, you create like a class.
Oh, you're saying if I put like instead of having a module teenager, if I have a class called teenager, let me actually open up the right one. This is not the right file. So you're saying if I change this module into a class and I include teenager here?
So you should, to be able to use the class, that you should not include the teenager. So
Oh, okay. So you're saying inside of here, maybe I will do something like def give person sass or something like that, and I can just do teenager.new.give sass. Is this what you mean?
Right.
Yeah. So the idea behind ice cream and freezers and stuff like that is that, and object-oriented programming in general, I guess this kind of goes in quite well, is that each class should do one thing. So that's why when we gave you the ice cream and freezers challenge, like if you're an ice cream maker, there are certain things that you interact with, and those should be their individual classes. So I'm an ice cream maker. That's an individual class because that's just me. I know certain things about other things. I know certain things about ice cream. So when I interact with ice cream, that ice cream is in its own object. It's its own noun. It has certain attributes. It has certain abilities that it can do things at. And I interact with it like by saying like ice cream.new. So within the ice cream maker class, I can call another class called ice cream.new. And then from there, like I'm an ice cream maker. I know how to take the ice cream that I've made and put it inside the freezer. The freezer is probably going to be another class because all it's supposed to do is just freeze the ice cream.
Yeah, because from your point of view, I know it's kind of like good to have the class to do one thing, and at the end it's simply they can have like many class, and from what I feel, you can have like many file that it's just the way it's supposed to look like many class, many file, and just have the main file to like link all the class objects.
Yeah, that is precisely what's going to happen. Yeah, so that kind of leads us into the concept of object-oriented programming versus functional, which is kind of something I wanted to talk about. Object-oriented programming is basically, it's two different, functional and object-oriented programming is two different ways to write a program. one is not inherently better than the other. It's just the way that you think about it and the things that you're trying to do with it. So when you have object-oriented programming, like this class person or this class high schooler, we're organizing code. So every single program has two things. It has data, and how do I interact with that data? The methods and functions and things like that. You can organize it in object-oriented program. You have all of your data directly inside the class, and you have all of the behaviors and all the methods directly inside the class so that you can look in one place and know exactly what it's doing. So if you're dealing with something, let's say you're writing a program that deals with like something that you can say exists in real life, like a person or a dog or or something like that, then you might want to use object-oriented programming to organize your code. In functional programming, not everything lives in one place, so I can just have like a whole bunch of methods everywhere, and I'm only using basic things like hashes and arrays and variables and numbers and things like that to talk about data between one thing and another. There was a great article I sent out a little earlier today that kind of illustrates it. So yeah, object-oriented programming, you can kind of think of it as anytime you see class, really, to be honest, it's immediately going to be object-oriented programming. It's basically saying all of the data that I'm going to need to use is directly inside of this class. All the methods that I'm going to do to this particular thing is also located inside this class as well. Inside of functional programming, there is no classes. There's just no classes. Any sort of data that you need to any sort of data that you're going to need to alter, and anything that you're going to, and all the methods you need to alter the data are going to be separate methods, and you're only using like hashes and arrays and things like that. It's not necessarily like one is better than the other. It's just two different purposes. If you're doing a lot of stuff with just data and you don't need to think of things in terms of like real life simulations, you can go ahead and use functional programming. It's a lot faster. But if you're writing code that requires you to think of like real life situations, like how does if you need to write any sort of code that deals with like real life situations, you're going to want to use object-oriented programming.
And if you're gonna use that concept all period, and you have to require relative. I mean, it's kind of like you have to have required to each one of them.
Yeah, as of right now, and you're starting to see that it's getting a little bit annoying. I have to require whatever file I'm calling inside of this file. If it's not inside this file, I have to require relative that file, require relative that file, and then I have to, if I'm using a specific library inside of person, I have to list them all up top. Require pry, require faker, require rspec, all of that kind of stuff. It's starting to get a little bit annoying. And this, right now, all we're doing is we're just writing pure Ruby. So Rails, when we get to like frameworks and stuff, this all goes away. I never have to type this on the top of the file again. It just knows as long as it all lives within the same app, everything is required. I can access everything at that point. But right now, we're just writing pure Ruby. So we're going to do it old school until we get there. All right, so we talked about modules. Namespacing modules is just methods like that you can import and export it between different classes. We talked a little bit about object-oriented programming. Is there anything else people wanted to know about object-oriented programming? If this doesn't apply to you, you can go ahead and start working on your stuff.
Just the actual use of inheritance.
Inheritance? That's going to come a little later. How about just basic things like what is an object? What are adder readers and adder writers? People want to see that again? Or?
And for the as an object here, when you create like a main file, like you have to create like the main file as a class too. Like what you did here is like, I mean, so if you have a different different class, so the main file is going to call like every class.
That's called a runner file. Yeah, the way that we're running this right now is that we're going to have a runner file for most of our code now, because it's kind of like if you have an individual class that goes inside of an individual file, the way that I interact with a program is going to call the teenager class, or call the high school, or call the person. Or when you did we do apple trees yet? So it's kind of like if I'm running an orchard, right? I know that I have my apple orchard. That apple orchard has many apple trees. Those apple trees have many apples. It's kind of like I, as a human being, connect all of those things together, and that's kind of what your runner file does. It's kind of like, go pick apples. Okay, I don't know how to pick apples, like by myself, but I know that one of my other classes knows how to pick apples.
And the best way you do is like you prefer to create the main file first and go with a small class.
I generally will like kind of figure out what classes I need and what they need to be able to do, and then I'll create the runner file actually last. Because the runner file is just kind of like how do I do things.
And that's kind of like what I would really like to, I guess, nail down that skill set of like thinking through it beforehand. So you just mentioned determining what classes you need, and like there's a process. It sounds like first you determine classes, and then think through that, like what each class is responsible for.
Mm-hmm.
What framework are you using to think through this?
I'm just trying to think of it in terms. Yeah, it's so. Maybe it would be helpful for us to tackle maybe one of the problems that you did not get to together, and then we can talk through my thought process. Would that be helpful?
I would listen.
Okay. Which one do you want? We've done bowling. We've done ice cream and freezers. We've done apple trees. We did schools yesterday. Schools is hard. Schools is really hard. Which one of those four would you like me to? Ice cream and freezers? Okay.
I was going to do ice cream.
Okay. So we'll just clone down ice cream and freezers, and I'll try to cover as many of these concepts as I can, initializing with a hash and all of that kind of stuff. So the most important thing to recognize about some of the challenges that you're going to start getting is that not everything is going to have super clear instructions. And that's because a lot of it is really up to you how you would like to implement it. So let's go down to here. We're going to clone down ice cream and freezers, cd into ice cream and freezers, and we're going to open this up in Sublime. Let's kind of see what we have here. So design the structure, releases, and all of that kind of stuff. All right. I'm going to pull this over because I don't like reading a note down. So this could be a very real problem that someone comes to you with, right? Let's say you are let's say you're Table XI. You are a consulting company. You have 30 people, and then Jim Oberweis comes up to you and says, "I need to create a program to manage all of my creameries," or something like that. Jim Oberweis is a politician who's from the Oberweis family of the family dynasty of dairy products. They do milk and they do ice cream pretty well as well. I think they have several dozen stores. It's a decent deal in this area. And this person comes up to you and says, I am opening up a store, I'm opening up a chain of stores, and I need to know what types of ice cream that, what flavors do we have for the day? And if I'm an ice cream maker, how long do I keep my ice cream in the freezer? I just need some way to keep this online. I don't know. Probably a bad example, but it's kind of like saying, I guess what's a real example? Yeah, we'll just go with this. So we have
Just want a program to manage.
Yeah, you want exactly. That's what it is. If you start with one store as an ice cream maker, you can do everything by yourself because everything is in your head. But as they automate and as they get into more larger and larger stores and things like that, they want to automate the process. They're selling their ice cream to many different grocery stores, so they have to have a factory. With a factory, you also come up with software to make sure that your ice cream comes out at a certain temperature all the time in the same way. So Let's read through this. I love ice cream as a creamer that makes delicious ice cream, growing rapidly. Okay. I want to make different types of ice cream. I want to place batches of ice cream in a freezer. As an ice cream maker, I want to know when a batch of ice cream is ready to be removed. So release 0. Design the structure. So before we dive in, we have to know like what classes are we dealing with? Can those classes be kind of dumbed down even more? And what should each one of those classes be able to do? Oh yeah, right here. What are essential classes? In terms of the classes themselves, what attributes, what kind of things are you going to initialize them with? How am I going to interact with each individual class? How will they interact with each other? How will they inherit, if anything? So before we even get started, actually, let's just read through all this. So additional features. I want multiple types of ice cream, each with a different freezing time. Makes sense. Like if you have gelato, it freezes at a different temperature than ice cream because gelato doesn't have a lot of air in it, and ice cream does. And it's kind of like when I put ice cream inside the freezer, if it's been in there for 2 hours, it's going to still be pretty watery. After 4, it might solidify a little bit. After 8 hours, it'll be like fully ready to go. And after 20 hours or something like that, it'll be freezer burned. I don't know if that's how ice cream actually works. And then we're going to refactor and get creative with it. So I just need to keep track of these 3 things, these user stories to get us started. I want to make different types of ice cream. I want to place batches of ice cream in a freezer, and I want to know when it's ready to be removed from the freezer. So what are some examples of classes that you would want to have in order to pull this off? In terms of a noun, like we're thinking not in programming terms, but just like you're an ice cream maker. Like
ice cream.
What's that?
Ice cream.
Ice cream is a class, yeah, I like it. So all my classes will be maybe ice cream. What else? Freezers. Anything else?
We have like somebody who's doing all the steps like checking, making.
True. So what is that person?
Chef.
Chef. Sure. We'll do chef.
Chef here.
I was going to do ice cream maker, but chef works just as well. But how do I know this number 3? It says as an ice cream maker, I want to know when a batch of ice cream is ready to be removed. How am I supposed to keep track of that? You had a batch class?
Couldn't that be in freezer level? Like?
So that's the question, right? And these are the types of design questions you have to figure out for yourself. There's no right answer. I could definitely do a batch. The freezer could know the timer. I could know the time. The timer can know a time. So it's kind of like, how would you like to move forward?
So based on what you were saying with gelato, whatever else, all having different densities,
Yeah.
freezing time. To me, it's intuitive. Ice cream, keep track of its own time.
So you also have to ask yourself, like, does that make sense? It is true. I know we're going with that, but in terms of, does ice cream as a noun know what its freezing temperature is or freezing time is?
You mean what is it normally supposed to be, or what is it presently at?
Like, if you were,
you could say that like vanilla freezes at X temperature, while
Yeah, but-
Rocky Road freezes at something else.
sure, but how do we keep? So it's kind of like, yeah, that is true. It's kind of like I'm vanilla ice cream. Let's pretend like these things are all alive, right?
Yeah.
I'm vanilla ice cream. I freeze at 32 degrees, and my freezing time is at 4 hours.
Yeah.
I'll be frozen at 4 hours. Where do I keep track of
The
that time,
status
though?
is going to
Right?
be like the freezer or.
No, the status is going to belong on the ice cream because it's like, hey, what's your status? Tell me about how frozen you are right now.
I thought the freezer would want to do that because it'd take.
The freezer is in charge of freezing. So it's kind of like we can. So it's kind of like, keep in mind that your classes are only supposed to do one thing. So ice cream should only just be able to tell you about itself. Like, what is my current state? What's my freezing temperature and my freezing time? Something else has to keep track of time.
Freezer's freezing under a single responsibility.
Yeah.
Freezer's freezing.
Yep.
The chef, she could be the one that places the ice cream in the freezer.
Correct.
And are you saying, are you implying that we need a fourth class maybe to say time it?
In a strict, yes, in a very, very strict single responsibility world, you need a timer class.
Because it almost makes sense to have the chef put it in the freezer
And then,
also time it.
okay, so, but it's kind of like if you were a,
And then the ice cream would have its own freeze time.
correct, yeah, the ice cream definitely has its own freeze time. But how do we keep track of time? So it's kind of like if you were, let's say, you make ice cream at home and you put it inside the machine and it spins, like how do you keep track of time? Do you ask the ice
Machine
cream,
that spins.
like do you ask the,
Like
like
set a timer.
you couldn't, yeah, and
That's
some
why I thought it
machines,
would be the freezer. 'Cause
yeah, the freezer could be one of those super advanced freezers and say like you can set a timer. It's kind of like an oven has a timer on it,
Exactly.
right?
Yeah.
The ice cream maker I have at home is not super high tech, so I actually just set it on my phone. So it's kind of like that's where I'm thinking like I might have a separate timer class. I could put it directly on the freezer. It could be a high tech freezer. And this is why I'm saying like these are called design decisions that you have to make. But whatever you choose, you have to live with. So just be aware of that. This is when you start organizing things like this right off the bat. Yeah, it's basically pick your fate. So if you want to have it as a separate timer class, the separate timer class is going to suck because it's kind of like I have to create new individual timers for every single ice cream. But if I
like the ice cream shop, like the same way you have, was it Baskin Robbins, right? Baskin Robbins and Dunkin' Donuts merged, so now I have donuts and coffee that also need to figure out its timer, and the chef needs to make sure they're timing all this stuff. Do I really want timer stuff to be so ingrained in ice cream that I can't time coffee anymore? Now I have to rip apart my class to accommodate coffee. Now the chef has to do both things.
So that's also like a scalability issue, right? So that's a very real thing. They have Baskin Robbins and Dunkin' Donuts put together. Like a lot of stores are like that. So it's kind of like if you were to write a program that takes care of that, the design use decisions you make right now is really going to impact you a little bit later. I'm going to put the timer directly on the freezer, just for the sake of just because I think that's okay for right now. Later down the road, it'll bite me in the butt when my store expands and I also sell donuts and cakes. Then it only lives on the freezer. Now from here, I know I have a ice cream class, a freezer class, and a chef class. I want you to talk about the attributes and the methods that will go on for the ice cream, for the freezer, and for the chef. So tell me a little bit, what are attributes for a ice cream? We kind of talked about already. So ice cream has a flavor attribute, yeah, it's vanilla, freezing time. And status is great, yeah. And then what else? Freezing temperature. That's okay with me. What methods what should ice cream be able to tell you? If it was like if this is Toy Story, everything is alive. If you can ask the ice cream things about itself, status is actually going to be on methods and attributes because it's something like when I first put it in, it has a status of being watery. Then I'm going to ask it its status again in a couple hours, and it might change to partially frozen or something like that. So these are things you have to think about in terms of like real life scenarios. This is kind of like that. If you can't think of it in real life, then use functional. But since we can imagine this in real life, it's going to be object oriented. Status. Anything else? Perhaps maybe something like, are you frozen? Like, hey, ice cream, are you frozen? Can I take you out? Like, can I sell you to a customer?
Isn't that status?
I mean, these are all, yes, we can merge everything into status. That's totally fine. But I'm saying like ideally, like, what else would you want to know about your ice cream when you look at it? Kind of like, what is the status of it? Like, is it frozen? It looks frozen, but like when you feel the sides, it could be like squishy, right? You kind of like when you buy ice cream, the top may look like it's frozen, but then you squeeze the sides and it's all like watery in the middle or something like that. That might be another method. It's like frozen. Maybe are you freezer burned? When you open up the top of your ice cream, sometimes it's freezer burn, right? So you look at it and you're like, okay, I register as that. I register that as freezer burn.
See, that's really confusing because when status, like, you have to get all that information.
It is, yeah, but it's kind of like saying if you were status can do all of it.
I mean, like, if we want to make different methods, one for frozen, freezer burn, liquid, melted, or whatever, like, I get that.
Yeah.
I just don't understand how you get at both.
Why I have both?
No, you just said it. I mean, status can be everything.
Yeah, status can be everything, but it's one of those things. It's kind of nice to just know it too, right? It's kind of like
But you can invoke ready, like or frozen.
Yeah,
we'll call it
frozen
ready or
frozen
something.
ready.
And it have a boolean. That's simple enough.
Exactly. Yeah. So I can check so it's kind of like the status is always going to change based on the amount of time that it's been in there, right? You put a steak in the oven, it starts off as raw, then it becomes rare, medium rare, so
You
on
don't
and so
care.
forth.
You just want to know when it's ready.
Yeah, I just want the most basic interaction with me with that piece of steak or me with the carton of ice cream is this ready to be eaten? Can I eat this right now? And then it's kind of like saying, yes, I can stick my thermometer in there and then figure out what the temperature is and then figure out the status from there. But it'd be so much easier if someone could just tell me, yes, it's frozen, it's ready to go, or something like that. So I think this is good for ice cream. If we take a look at freezer, what are some attributes to the freezer? This is where some things get a little bit hairy. Capacity.
Name.
Freezer.
1, 2, 3.
Yeah,
4.
like a freezer number. No, we'll call it name, sure. And the freezer has a name, it has a capacity, and it has what's that? Temperature, yeah. I think that's all that we probably need on there. Methods, like what is a freezer able to do?
Time.
Okay.
Timer.
Maybe a set timer or something like that. And with that, like maybe like time remaining or something like that.
Yeah.
And a freezer has the ability to freeze, right? I think that's about it. And the chef, we can make this one a little bit more fun. This one doesn't really get it.
I think the method for freezer should also tell you if it's full.
Yeah, that's great. That's actually fantastic that you think about that. Because if you think about capacity, it's kind of like saying like people keep passing you stuff, but if you don't have that method saying like I'm full, like then they will keep passing you things. Okay. What about a chef? What is a chef able to do? Yep.
Make ice cream.
Yeah, make ice cream. Make ice cream.
Put in freezer.
Put in freezer.
Take out of freezer.
Take out of freezer.
Check freezer. Like check temperature.
Check
Status. Check status.
check ice cream status. And we'll just give the chef
Name.
We'll just make it real simple. First name. Okay. All right, so this is around how much time, like this probably takes more than 3 times as long when you actually start writing real software like this that actually has real impact on people's, like this, these are the decisions you have to make. At this point, somebody might say like, I disagree. I don't think a freezer should set the timer. Like I think the freezers should just freeze and the timer that you set associated with the freezer would be, you know, or like a freezer has many timers, right? Like I have like, maybe I'll set up 8 egg timers right next to each one of the shelves, and I can twist it for that particular ice cream. Or maybe the ice cream has a timer on top of it. You know, like there's many ways of doing it. This is just the way that we chose. But we have to live with this no matter what. And I'm starting to see some issues, but we'll figure it out when we get there. So we have the ice cream class, the freezer class, and the chef class, and we can just start from there. So I can throw everything here to begin with. I'm not a big fan of that, but it's okay. Class, chef. All right, so how do I, first things first, we know we have attributes of flavor, freezing time, status, and freezing temperature.
Oh, and also, why don't we put each class on a different tab? Do we need to do that? Or we don't? Or like, what's the...
I'm going to put it in different files pretty soon. I just want to get this all. I want to transfer everything from my thoughts into here, and then I'll split it. So flavor, freezing time, blah blah blah. Then I know I'm going to probably need to read all these attributes. So same thing: flavor, freezing time, status, and freezing temperature.
Why do you have to pass the status?
Because what if you like, let's say your freezer breaks, right? And you're like, quickly, let's put it into another freezer. You need to know what the current status of it is. You know, like
Can't you just get that from without passing it to initialize?
Yeah.
Can't you just get that from the method?
You're asking whether another class can get that?
No, he's saying
No,
why
like-
if when I create a new ice cream, why would I pass it? Why would I tell it what its status is? Again, these are starting. Now we're starting to figure out the shortcomings in our code. So could I put status somewhere else?
Because status is just a function of time.
Yeah, that's fair. I'm gonna take it out. When I create ice cream, I don't tell it what status it is. It just is a status.
I think it's still valid to have it as a reader.
Yeah.
The reader is fine.
You're right. I'm just not going to initialize with it. So I was going to get to that.
Oh,
When we get there. Yeah. Okay. I know that it needs to do something with the status. I know that I need a frozen. You want to call it frozen question mark or ready question mark? Ready? And then freezer burn. So I just transferred everything from here. Now this is gone. Next, I have my freezer. So I'm just going to grab this, put it inside and initialize. Make them all readers. I'll fix this later. And you said that this freezer class has the ability to set timer. This freezer also has the time remaining. Also has a freeze, def, full. Good, we just got rid of this one. And finally, the chef. Chef is easy. Let's initialize first name. And the chef has all of these here. Def, make ice cream. Def, put in freezer. Def, take out of freezer. And check ice cream status. Cool. I have 3 different classes. I've just more or less just shoved it all in one file, and I'm going to just separate it. So I'm going to get rid of this, change the name of this just to icecream.rb. I'm going to create another file called freezer, freezer.rb. And then last one called chef. So now I have 3 different files, and each file only has one class, and each class only contains all the things that specific class is supposed to do. I'll split this for now. Sizing is still okay, or is it a little hard to read?
No, I think it's fine. Can you give me a second here with so the adder reader?
Mhm. You look at that, and then I will continue to fix this up.
So we just wanted to be able to read that.
Is this too small?
This.
Better? Or one more?
More.
More?
That's good.
Okay.
Sorry. So why do we have to make it an adder reader when we're making it an instance as well?
It's just shorthand. You don't have to have adder readers.
Yeah, I mean, but because we're calling the instances out, right? Like you don't need that at all. Like it's almost like you're doubling down.
So it's kind of like this adder reader basically means that I don't have to do @first name inside of here ever again. I can just call first name without the @ in the front, and then I can just call it. Yeah. I'm doubling down, so it's just I'm saving myself keystrokes later. So we have these 3 classes. They take in their specific arguments. I made them all readers, so that the moment I declare it with an @ symbol in the front, I never have to use whatever to call it again. I can just call first name, and then it knows to look inside of here. Now I wanted to talk real quick about ice cream. You see that I'm passing in 1, 2, 3 things.
I thought we're not passing steps.
Let's just give me a few more things about ice cream. I want to talk about hashes real quick. Give me 2 more things about ice cream.
Flavor,
Freezing time, freezing temperature,
calories.
calories, sure.
My favorite one, I did the light factor.
The light factor, sure. Right.
It seems like we're going to run into a problem with the freezer temperature.
Yeah, it's possible. We're gonna have to live with that. That's why I said whatever we choose, we're gonna have to live with. But before we get there, I want to talk about instantiating objects with a hash. You can kind of see I'm passing in 5 things. So let's say I want to use this, right? I have ice cream local variable equal ice cream dot new, and then I pass in a flavor of chocolate. Freezing time is going to be 60 minutes. Freezing temperature is going to be 25 degrees. Calories will be 100 per serving. And the light factor is wonderful. You can kind of see I'm passing 5 things in a specific order. And it has to be in that order because I'm expecting the first thing to be passed in is flavor. Second thing I'm expecting is freezing time, freezing temperature, calories, and the light factor. Now, I've named my variables and all of this kind of stuff here specifically to match up with those things. But what if I didn't want the degrees here? and I just have numbers 60, 25, and 100. This is no longer descriptive. And if I mix it up by accident, now the freezing temperature is 100 degrees and the calories is 25. That's not very likely to happen. But this kind of stuff happens all the time when I have to pass in 5. Let's say you're creating a brand new car, right? Every car has a make, model, year, VIN number, paint color, engine type, all of that kind of stuff. What if you mix one up by accident? Or just like what we saw here, what if I changed the calories in the freezing temperature? Now this is saying someone's going to tell me that, no, chocolate ice cream freezes at 100 degrees. Like that's not possible. So with this, we want to, when you probably get over 3, probably if you get to 4 or more things that you need to pass in at once, you might want to start using a hash. So that, let's say, ice cream hash equals flavor chocolate. Am I missing anything? Calories. So I create my hash outside or directly inside of here. It doesn't matter what the order I put it in because we're separated by key value pairs. And then instead of expecting it in a very specific given order, I can just say ice cream hash or whatever I'd like here. And then from there, I can choose so it doesn't matter what order I pass it in. Like if you can kind of see before I had to worry about like it has to be in order of flavor, freezing time, freezing temperature, calories, and delight factor. I can pass it in however I want inside of this hash because when I pass it in, the flavor of this ice cream is going to be looking for the ice cream hash's specific flavor key. And then the freezing time is going to be looking for the ice cream hash's specific freezing time key. So this way I don't have to worry about order. It's far more, I guess, stable.
So you have to create the hash with the parameters and then pass in the hash argument. It seems like a lot more work.
It is more work, but the thing is kind of like if you switch one thing, you just screwed up everything. So you can kind of think of it like if you had to have specific steps in a specific order and you mix up step 6 and 7, you have chocolate ice cream that you're going to end up boiling instead of freezing, right? So it's kind of like one tiny little mistake from an engineer, which happens all the time. One tiny little mistake screws up your entire program. It can cost you millions of dollars. So that's why, generally speaking, if you're passing in 1, 2, or 3 arguments, it's okay. You can keep track well enough to do, like the first thing has to be the temperature, and the second thing is the flavor, the third thing is the calories. That's okay. Once you get to 5 or 6 types of thing, it's pretty rough, right? If you're selling a used car has 15 things that you need to know about, right? What's the odometer reading? And then what is the current value, right? If you switch those two, your odometer reading is 180,000. It's, it's saying and it's, its value is $5,000. That's saying you're saying I have a 5,000-mile car that is worth 180 grand versus I have a car that has 180,000 miles on it that's worth $5 grand. You'd be surprised at how often this happens. So again, when it comes to these things, you just want to be absolutely certain of what's going on. I'm going to go back to the way things were. I've lost everything.
So when you instantiate new flavor, for every instantiation, you have to have a new hash and a call to that hash.
Yep.
Or a new variable declaration.
Yes. Yep. I mean, I don't have to have this. I don't have to declare here. I can just do that. I can just pass it directly. Yeah. So let's just do p ice cream dot flavor freezing temperature. We'll just run this. We'll just see what happens. Ruby ice cream. Alrighty. Chocolate 32 and 100. So I'm passing in the hash of information that you need, and then based off that giant hash, we can trust that it's all the data is in the right place because we're passing in and specifically by key value pair. You're going to set your instance variables to that. I'm going to get rid of the light factor and calories, and we're just going to go back to just 3 things. Flavor, freezing time, and freezing temperature. Comment this, comment this. All right, so let's kind of continue on here. We got this ice cream, the status. This is where we're going to start thinking about the actual code itself. So if I have a status here, basically it's, now I don't know. Now it's like, how do we figure out like something status?
Well, it's going to be based on time, right?
Time and temperature, right?
Yeah, so I feel like temperature is going to be a...
Temperature actually would probably be a better gauge, right? Because it's kind of like if you're making ice cream on a really hot day, the temperature that you first put it in at, if you're making ice cream in the winter versus the summertime, and it's like not a, let's say it's not a air conditioned room or something like that, it's just the temperature of outside. And the time that you put your ice cream in a freezer will, like,
Right, in the real world,
yeah.
I get it, and I think programmatically it should reflect that, but for our purposes now, like, I think it's gonna be hard to, because every time now that we instantiate a freezer, we're passing in a temperature as well, and if the temperatures aren't the same, it's gonna affect the freezing time, and we're not gonna be able to manage that change.
Yeah.
I mean, at least I don't think it seems a little more complicated than
but in terms of that is all legitimate. But in terms of, we're just trying to worry about the ice cream right now. How does the ice cream, like if you were ice cream and you're real and you can talk, how do you know what the status is? It's kind of like if you are water, how do you know if you are ice, water, or mist, or steam, right? It's based off of temperature. So that's kind of why I'm going for temperature. Like, oh crap, the ice cream doesn't have a current temperature. That might be something that's useful, right?
yeah.
That's okay. We'll pass that in. It's greater than 32. Else if the current temperature is equal to the freezing temperature, frozen. Else it's greater than freezer burned. So it's just kind of like the status is based off of the current temperature of the ice cream, right? Kind of like water. Like, what's the current state of the water? Well, what temperature is the water, right? If it's 33 degrees, then it's not frozen water. If it's 32 degrees, then it's ice. If it's 212 degrees or higher, then it's steam. Similarly here, if your current temperature is greater than 32 and it's currently greater than freezing temperature, then it's going to be watery, right? Because it hasn't frozen yet. If I have a current temperature equal to the freezing temperature, it's frozen. Otherwise, it's going to be freezer burn. Like this is very black and white, but ready might be like status equals frozen. That might just be it. Like, what is the status? Is it equal to frozen? This will return true or false for us.
Status.
So status is a method, right?
No, I'm sorry, the ready status, but why the ready method?
Mm-hmm.
I don't think if it's
This one's
if current temperature equals
it's ready to be
freezing temperature.
Yeah, that's
True.
That's totally fine. I mean, like this.
Yeah, like if there.
You just do that instead of this.
Yeah.
Yeah. It's like, is it ready? Well, tell me the current temperature. Is it equal to the freezing temperature? If it is, then it's ready. That's fine. These two do the same thing. It's really up to you what you would like.
Oh, gotcha.
Personally, it was just kind of like, for me, when I was
frozen. I see. Yeah, frozen was ready. I didn't understand. I got it. I see.
And then freezer burn is basically like status equal to freezer burn. That's pretty much all we did. This. We instantiated ice cream with 4 things. It was 1 hash, but we got 4 pieces of information from it. We basically said, what's the status of the ice cream? And status is based off of temperature, similar to how, like, what's the status of the water? If it's above 32, then it's water. If it's below 32, then it's ice. If it's above 212, then it's steam. So similarly, I said, like, if the current temperature is greater than the freezing temperature, then it's watery. It's not frozen. If it is equal to the freezing temperature, then it's frozen. Otherwise, it's going to be freezer burn. This is very, very delicate ice cream. If it's not exactly at that temperature, then it'll die. And then ready is something that you're asking the ice cream. It's like, hey, are you ready to be taken out? And that's only going to return true if the status is frozen. And then freezer burn is basically, are you freezer burn? And it's going to say, let me check my status. And the status is going to be like freezer burn. Feeling okay about ice cream so far? All right, let's jump over to freezer. Okay. Freezer has a capacity, nickname, and a temperature. I'm going to get rid of the nickname because I don't want a nickname. I don't want to deal with it. And again, this is just 2 arguments. I'm just going to keep it as just in order like that. I'm not moving to the hash because the hash has 4 things, 4 or more. Right. So freezer has a capacity. It has a temperature. I'm going to set a timer on the freezer. And how's that going to work? Really, no idea. That's the thing where we kind of like, where does this start to break down? When we kind of jumped the gun and we kind of said. We jumped the gun a little bit and we said, like, we'll just put the timer on the freezer. Like, how are we going to implement it now at this point? So we just said that it's going to be pretty difficult. So do you want to keep going down this path or do you want to abandon ship and go down another path? There's no right answer. It's just going to be a different outcome.
Can we try this one?
What's that?
Can we try like this one and then?
Sure.
If you have like another way.
Yeah, sure. We'll do it this way, and then we'll figure out what to do next.
What's the new sticker?
I got a new sticker from Denver Startup Week. It was this little was like a little stand that basically just gave out free T-shirts to promote their small printing press shop. Kind of fun. So I got two T-shirts, a free bag, and a sticker for doing nothing but showing up and pretending to show interest in their company.
So do they make you? They watch you put it on your computer?
No, I just
Thing?
got it because it was kind of fun looking. But no, they just said like, which shirt do you want? And I said, I like this design. And then they laid out the shirt. They had a printing press on there, and they just silk screened it and then threw it through like an oven, more or less. It kind of like looks like a pizza oven, and just dries everything really fast.
Yeah.
So it's pretty cool. I think I got 8 shirts on this trip. Yeah. I'm good for a little while. I have no issue like
It's enough for one.
that is true. I should have thought about that. Should have got everyone souvenirs. But I need workout shirts, so ran out of workout shirts. All right, so set timer. Jeez. A freezer also needs to be able to tell me what ice creams are currently in it, no?
Yeah.
Like, I should be able to look inside a freezer and know what's in there. Yeah, Jesus.
That's why. Yeah.
So inventory is a method here, but I'm also going to need to access it over and over again. So it needs to remember things about itself. It's kind of like the inventory when I first started, I was going to be empty. But then when I put stuff inside of it, the inventory is going to change. So when I ask you what the inventory is again, it needs to know what that is. So that's why I'm going to have it as @inventory.
So I don't know what that one means.
Sure.
Pipes and.
So this double pipes is or equals. It's called memoization. What's happening here is if inventory is empty, if there's nothing inside of it for right now, I'm going to just say, okay, it's equal to empty array. If it's not empty, if there's something, if @inventory equals anything, then I'm going to just return @inventory. That's basically what it says. If it's empty, put this instead. Set it equal to this. If it's not empty, just return me whatever that not empty is. So I've created this @inventory because I remember I have to keep track of it throughout my entire program over and over again. So I put it
throughout your entire class.
I'm sorry, throughout the entire class. And with that, I'm going to throw inventory as an adder reader. And since it's just going to be an array, I think I can push onto it without doing anything. So I think it'll remain an adder reader. So I need to keep track of inventory. I need to keep track of a timer. Time remaining. Freeze.
Well,
This, by default, a freezer freezes. I don't think I need this either. Full is pretty easy. It's just kind of like if capacity. Go ahead.
yeah. Because I was thinking maybe set more of a instance variable, but if capacity equals whatever number, then true. Yeah, or yeah, like that. Just like,
Cool. Like that. Basically, if the capacity of the freezer is equal to your inventory, like how many ice creams you have in your inventory, then you're done. You don't have to do anything.
would it always be full?
No. Else.
Because if you put if you put 2 ice creams in your inventory, then you're always at inventory.length. Capacity equals.
Say that one more time.
Let's say you put 2 ice creams in your inventory, in your array. You're always going to be at inventory.length. Like there's no.
Capacity is what you. So it's like I have a freezer. It can hold 5 things. My inventory when I first start off has nothing in it. I put 2 ice creams in it. I still have room because I have 3 left over, and that's what this
so,
step
but
full.
we're not declaring what capacity is.
We're passing that in right at the beginning. It's kind of like a freezer has a built-in capacity, right?
Yeah, yeah. Okay, okay. I see. I see.
It's kind of like a mini fridge that can only hold X amount of
Okay.
space, like 1 cubic foot or something like that. It's okay. I'm going to refactor this. And
You can just delete the true and false, right?
I can just do this. So it's basically like capacity is going to be a number. Does it equal whatever your inventory.length is? That's going to return you true or false right off the bat. Freezer. Jeez.
So how are we going to add stuff into the
That's a great question.
You gotta add to freezer.
Is it a freezer's job to add stuff
No,
to the
it's
freezer?
chef's.
It's a chef's job. Okay.
I think we had that check.
I think so. Let's take a look. Chef, make ice
Put it-
cream,
put it
put in freezer, take out a freezer. Cool. This set timer thing, the timer thing is really getting to me right now. I'm not sure where to put it. It could be put on the freezer directly. It could be a separate class. It could be on the chef. Hey, keep track of time or something like that. But a freezer has a timer, but if you put things in at different times, then that timer doesn't really apply anymore, does it?
Well, you just have different batches of times. Like you could put in vanilla and then 30 minutes put in chocolate, and just the same freezer but at different time periods.
Yeah.
So I thought ice cream was.
Exactly. I don't know. Ice cream has a timer on it. Ice cream. Sure. That actually makes things easier. So we're going to get rid of this. Freezer just keeps track of the capacity, the current temperature that it is, and the inventory, and it can tell you if it's full. Wow. Ice cream does a lot of stuff. You're going to start seeing, and this is what I want people to start seeing, like, once a class gets super long, it's probably prime time to refactor it, make it smaller. This is where, like, strict OO principles, like in having that knowledge of a timer should probably be its own class is probably a decent idea. Right now, we're just going to do the cheap way and just make it work. We're going to throw it
If the
through.
timer was a different class, then you'd have to instantiate a timer every time you instantiated it.
That's right.
That's a pain in.
That is absolutely correct. Yeah, it's very, very annoying, but it is a clean way of doing it. So every single time I put something in the freezer, I create a new timer specifically for that ice cream. Like that ice cream, that timer would specifically belong to that particular ice cream I'm putting in at that moment. And the set timer and timer manage, like we're more or less doing the same thing here. Let's see, set timer. Let's just do at time put in equals time.now. This time.now, this capital T, is one of those things that's built into Ruby. It tells you exactly what time it is right now with a timestamp. We're not going to talk too terribly much about time zones, but time zones are the bane of everybody's existence. Because you can kind of see right here, this negative 0500 is because we're on Chicago time. So UTC time is somewhere in Europe, and we are 5 hours behind that. Thus, we are negative 0500 from UTC. So it's kind of like 2:56 in the afternoon. Where? You know, where? Like, I'm going to run this job every day at 2:56. Where? You know? Is it going to be based off of UTC time? Because then that's 5 hours ahead of Chicago, or 4 hours ahead of New York, or something like that. Just kind of give you a taste. So we have the time put in. Ice cream, I'm going to set the timer.
Wait, I'm sorry. What was the negative 500? Or 0500?
So the world's clock is based off of a concept called UTC.
Yeah.
UTC. I think there's an atomic clock somewhere in Europe.
Greenwich, right?
Yeah. So Greenwich time says that this is absolute, like, this is what time it is right now, based like that's the most accurate clock in the world.
Yeah.
Now we have specific time zones, and we can go like plus whatever or minus whatever.
Yeah,
So,
I get all that. So it's 0500 in Greenwich right now. That's Zulu. So Zulu is 0500 right now.
Sure.
yeah, so I'm guessing in Greenwich right now it is 1956. We will find out. Let's current time in Greenwich. We are. Is it daylight savings? Yeah. UTC. 7:58 p.m. at the coordinated universal time, and we are -5 from that.
Okay. Yeah.
And
it's
that's
easy. Okay, got
basically
it.
what it was.
Why is it so? Like, why is that tough for implementing later on? Like, different.
It's basically like saying if I want to open, like, this is an obvious one that's been kind of like we've solved this already, but it's kind of like I want to open the markets at 9 a.m. Is it 9 or 9:30? 9:30. So I want to open the markets at 9:30. But if I don't pass in a time zone, it's based on whatever server is hosting my program.
Yeah.
So if I have if my server lives in Asia, 9 a.m. there is not 9 a.m. in New York time. It's 12 hours ahead. So at that point, it'd be like I'm opening the markets at 9:30 p.m., which is highly illegal. There's regulated trading hours. So we have to worry about time zones in that sense, where it's like I want to open the markets at 9:30 at 0400, negative 0400 from UTC.
Of all the things that we've covered, this seems like the easiest. Does anybody else be like, this does not seem so little? Like, you have to be like, you're.
Can't you just like add a couple ones on the
Exactly.
the hours and
What happens when there's daylight savings time?
Then that's
Subtract
another thing that then
But
it's
you
not
have
biased.
to account for all of that so that your programs will work at a specific point.
at a specific day.
Yeah.
It incorporates the.
Yeah. So it's kind of like, hey, if it's between these two dates, like then I'm going to add one to all of this logic, and then if it's not that, I'm going to subtract one from all of this logic. And then if you have, for us, like when I was working at Groupon, the big thing with time zones was we're operating around the world. So it's kind of like, I want this deal to go live at 9 a.m. Where? That was the big question always. It's like we wanted to cover ourselves. So it's like, we're going to open it at 9 a.m. Chicago time. And then before we do it, it was like, no one's going to open this. It's 9 p.m. in China, So time zones is interesting. There's a lot of things you can read about that. Can we just not worry about time?
Yeah, cool. Like we're good on progress.
Chef, check ice cream status. Let's just do. Watery, frozen, freezer burned. So I just simplified it a lot. I just said the ice cream takes a flavor. Actually, we can get rid of this. I'll keep this hash just for demonstration purposes. It takes in a flavor. It tells me its status. It's just going to choose one of these at random. It's going to tell me if it's ready, and this ready will call status and say like, is it frozen? And if it 1 out of 3 times it will be frozen. And then is it freezer burn? 1 out of 3 times it's going to be freezer burn. This freezer has a capacity of something. The temperature, it's fine. We won't do anything with temperature. And then finally, it has an inventory of like all the things that you can push out in and out of it. And then full is the capacity equal to the length. Finally, we get to the chef. Chef has a first name. The chef can make ice cream. Now, this is the point where we're starting to incorporate other classes into this one class, right? Because I have a class chef making ice cream here. I can just create an ice cream like this. So I'm just going to do ice cream .new, and I'm going to pass in a flavor of Rocky Road. Then I'm going to.
This is going to be the driver code or the what
Could be.
The runner.
This is not technically a runner. It's just a class that interacts with other classes.
But when we instantiate a chef,
the chef has the ability to make ice cream. It has the ability to put things and take things out of the freezer.
okay, so we would call the chef, and then
Yeah, the runner file would call the chef to do things.
Yeah.
The chef by itself is just like I can do things, but you can tell me what to do.
And when you just said def make ice cream, you gave it an actual ice cream spec.
Yes.
Okay.
And that freezer, let's say the chef has one freezer.
But so this chef can only make Rocky Road ice cream.
As of right now, yes. So let's say the freezer, and it has 5 things.
That's cool.
Let me just do this for now. How do I delete a specific thing without active record, Kara?
Wait, delete a specific thing?
Mm-hmm.
I think you can just do delete, or if you shift or push, are you trying to save the instance of it?
I saved the int, so I'm pushing the ice cream into the inventory of the freezer. How do I take it out? I think it's just delete. We'll see if this works. But essentially what we have here is we have this chef. The chef has a first name. That's about it. Or we're never going to use first name, but it's fine. The chef is also dealing with the freezer. Like right away, let's pretend it's a very simple program. I'm one chef and I have one freezer. So I'm going to create a freezer in this initialize because I can't be an ice cream chef without a freezer. I can't, if I can't freeze things, then I don't have ice cream. So that's what I've done here on line 6. I've set @freezer equal freezer.new with 5. That 5 refers to the capacity on the freezer. I'm going to make an ice cream. That was the first thing I was going to do. So I did @ice cream, an instance variable, and then I made it an attr reader so I'd never have to call @ice cream again.
Why are we doing this just for like, are we just trying to give an example of like one time that we did this? Like
Good.
just, we're doing a very specific thing, right?
Oh yeah, I mean I could totally just do flavors equals like vanilla, strawberry,
Yeah.
chocolate.
Yeah.
And I can just do flavors.sample.
Yeah. Okay.
Could do that. So I'm creating an instance of the ice cream class. So @ice cream here is equal to, has all of this information inside of it. It knows that my flavor is going to be whatever this flavor is. And then I can call ice cream, like lowercase ice cream, .status and .ready and .freezer burn and so on and so forth.
Have we called? We
haven't done anything yet.
We haven't done require.
Good point. Good point. That actually makes sense. That's what I've broken. Require relative because it's a file. And it looks like chef and ice cream are at the same level. So I can just do ice cream. Look. It's also, I probably need freezer because I'm calling another file into this. So require relative for freezer. Good call. I think that's about it.
What about ice cream?
I did.
Oh, sorry.
It's up here. All right, so I'm going to put it in the freezer. So again, when I first created my chef, I needed to immediately have a freezer. So I'm going to have this freezer. The freezer has a method on it called inventory. If inventory exists, then I'm going to return inventory. If not, I'm going to set it equal to an empty hash. The first time I do this is going to be an empty hash. So I'm going to push in the ice cream into the inventory. And then I'm going, if I wanted to take something out, I'd freezer.inventory. Delete ice cream. I don't know if delete will actually work. We'll actually find out. 1, 2, 3, a equals underscore a dot delete 1. Yeah, I think that's all it was. Just find it and delete it. And then ice cream status. It just says check the ice cream status of something. I'm just going to look at the ice cream that I've created and say give me your status. And I look over here. Status is going to return me one of these random ones called watery, frozen, or freezer burned. So this is not necessarily the runner file. This is just simply a class that calls it other classes. The runner file would look a little more something like this, if I'm not mistaken. Actually, let me just delete this. I'll just call this like runner.rb for a runner file. And for this one, unfortunately, I have to require everything. So require. And then this is basically where I start writing all of the driver code that pulls everything together. I'll call this Taylor chef is equal to chef.new. Taylor. I'm going to have Taylor chef make ice cream. Okay. I'm going to have Taylor chef put ice cream, put in freezer. So I pushed it in the freezer, so I'm going to ask, I'm going to say Taylor chef.
Which ice cream is that?
It's a great question. So on line 5, we created a new chef. Haven't done anything with it.
No.
We just know that the first name is this, and the freezer is a brand new freezer instance with 5 capacity.
Oh, add ice cream equals. So you reset. You gave it a specific value.
Mm-hmm. Yes, and then I said make ice cream. So that particular ice cream, I basically said I'm going to choose a random flavor. It's going to be saved to the instance variable at ice cream.
In the ice cream file.
So this is, on the left side of the equal sign, is specific to chef. On the right side of the equal sign goes into ice cream. Well, actually, let's not go too far. We'll put a fire fry. Okay, so I ran the runner file. It created a new Taylor chef, and then I said, Taylor chef, make some ice cream. And then it stopped right here. So this is where we're at. So flavors is a local variable just specific to lines 13 through 17. And it's just an array of stuff. Next things, I'm going to type exit. And it's going to hit this line, ice cream.new, and it's going to jump into ice cream, like the ice cream file. Now I'm inside the ice cream file, and I'm saying at flavor equals ice cream hash flavor. So at this point, all I've done, created a brand new Taylor chef, told the Taylor chef to make ice cream, and now Taylor chef has ice cream associated with itself. And that ice cream is going to be, this object right here. So at ice cream is actually equal to this thing.
Okay, can you go back to the code at least one? So that at ice cream, where's that now stored? So we changed it, right? So that could have been a couple of different things.
Mm-hmm.
But now we changed it to strawberry. Now where is that? Right now it's in like.
So this is an instance variable.
Yeah.
I made it a reader.
Yep.
So I have the ability to call .ice cream, which will read the instance variable.
It could be like a writer or like a what's the other one? Accessor if you wanted to change it. And you're changing.
I'm not changing anything. I haven't made a new ice cream yet.
But that you're saying you're setting at ice cream equal to something that
Yeah.
could be random. Isn't that changing it? Isn't that manipulating its value?
It's not the original. This is doing it the first time. If I were to manipulate it again, yes, it's different.
An instance manipulating an instance.
Yeah.
That requires an accessor.
That requires an accessor. So if I did Taylor Chef make ice cream again, I think this blows up. Oh, I know what it is. I got it. There it is. So if I want to update it outside of the class,
Taylor Chef that ice cream. Okay.
equals something else. If I wanted to modify it outside of the program, then I have to have ice cream as an adder writer, and since it's a writer and a reader, it'd be adder accessor. The issue, because I don't have that, it blows up here on line 9. It says there's an undefined method ice cream equals. Like you can't write to it. If I were to change this to adder accessor ice cream, then I can do whatever I want.
You put it in the freezer.
Pardon? I have not put it in the freezer yet. Fix my ice cream. So now Taylor Chef, once this Taylor Chef makes the ice cream, we are going to put it in the freezer. At this point, I want to see what is in the freezer. So Taylor Chef dot, why don't I just say see what is in freezer. Basically freezer.inventory.
Where did our freezer go?
It's right behind here.
Oh, instead of checking the inventory?
So it's kind of like, okay, so Taylor Chef puts the ice cream in the freezer.
Yep.
Taylor Chef will also see what's in the freezer next. And that method, see what's in the freezer, basically says, okay, I know how to do that. I'm going to walk up to the freezer and look at all of the inventory that I have inside that freezer.
But couldn't you also do just print p freezer.inventory? You don't have to call the chef to do that.
I mean, here?
Freezer.inventory, yeah.
Where is freezer?
Can't you in the freezer column?
Could, but that's not the freezer that's associated with the chef. That's just a random freezer. This is just the class. This is not a specific instance of freezer. the specific instance of freezer that's associated with the chef is the one on line 10. So I have to go, in order to get this specific freezer that I put the ice cream inside of, I have to go to the chef to say, like, show me your freezer's inventory. Like Sub-Zero makes a ton of freezers, right?
Yeah.
But Sub-Zero also ships a bunch of freezers out to other places. And if you want to see the one, like what's inside this particular Sub-Zero fridge, you have to go to the owner of that fridge and say, show me your freezer and show me what's inside. I can also do tailorchef.freezer.inventory. So this is the inventory that they have. It's an array with one thing inside of it right now. And I can also do tailorchef.see what is in freezer. Should be the same thing. Obviously it changes, but. And then we kind of continue on with this. It's like, take it out of the freezer, and so on and so forth. So we had a freezer full of stuff, then we deleted it, and now it's gone. Now we have an empty freezer, and so on and so forth. And then you can check ice cream status and stuff like that. So the runner file is basically like, how do you want this program to run? And then the classes themselves have specific methods and specific attributes. Does this help a little bit at all? Yeah. Okay. I'm going to stop talking because I have no voice left. Yeah, we'll pick up. We'll pick up on a little bit on super and inheritance.
Where are you going to keep those?
This one? Let me just send it to you.
Yeah.